All right, today we're going to talk about finding different arc measures within circles and related to how we name those arcs and looking at central angles. So first off, we're going to talk about the measure of a minor arc. And so in this particular case, when we're talking about minor arc A to B, we're talking about the shortest distance on that circle to go from A to B. It's not the segment A to B. We're talking about that arc symbol right there is talking about reading it on the circle and going from A to B. And if I wanted to go the other direction, then I would be talking about the major arc. And then I would include one more letter to let me know that I need to, this is letting me know I need to hit D before I get to B. So I got to go A through D and then I hit B. And the relationship between those two is always going to be 360 degrees. A circle is always going to add up to 360 degrees. And so whatever you have for the minor arc, in this case it is 50 degrees, then the major arc would be 360 divided by 50. Subtracted by 50 to get 310. And then the last thing, when you cut a circle in half or the semicircle, you would get that a semicircle is 180 degrees. Just like our addition postulates of segments, same thing with arc addition. If I wanted to say that I wanted to find out this entire measure of an arc, then I would just add up the two arcs that I have to equal the sum of that one arc. So for the first question, find the measure of an arc of circle C where AB is the diameter. So first off, recognizing that AB is the diameter means that I am cutting this circle in half, which means that I'm going to have this whole thing is going to be equal to 180 degrees. And because this is a central angle, then I know that this arc up here is also going to be 65 degrees. And so since this whole thing is 180, I can subtract my 65 from 180 and will be left with 115 degrees for dB. So if I want to find the measure of arc AD from A to D, it is going to equal 65 degrees. If I want to find the measure of arc DAB, so I have to start at D. I cannot go directly to B. I have to go through A and then to B. I have a 65 degree arc plus the semicircle, so it's going to be 65 plus 180 to get 245 degrees. And then for BDA, I'm going to start at B, go through D, hit A, and that's going to total 180 degrees. Same concept here in number 2, so if you could pause the video and quickly solve for the different measures of arcs in number 2. So for this one, we have a right angle here and a right angle here. So when I talk about S to Q, I have 90 here, so I'm going to have 90 and 35, which is going to equal 125 degrees. When I do R to P to Q, I'm going to start at R, hit P, and then go to Q. I have a 35 plus this side, which is really just cutting off the diameter, so I'm going to have 180 plus my 90. It's going to be 270 degrees. And with PRS, start at P all the way to R. That's a diameter. That's a semicircle, so it's going to be 180. And adding my 35. So 180 plus 35 is going to equal 270. 15 degrees. Number 3 is looking at a survey where it asks people how many minutes they spend brushing their teeth each morning. The circle graph shows the results. Find the indicated arc measures. First one, start at A, go through B, then hit C. I have a 120 degree arc plus an 82 degree arc, which is going to equal 202 degrees. For ACB, I got to hit C first, which currently is 145 plus 13, but then I need to also go to B, which is going to be plus 82 degrees, which is going to total 240 degrees. For B to D, starting at B, through C, and then D, that's hitting an 82 degree arc and a 13 degree arc, so it's going to equal 95 degrees. And then lastly, CBD, C through B, all around a D is including everything but 13. So I could do the circle minus 13, or add up each one and get 347 degrees. So number 4, we're going to look at, in some cases, different circles, or in some cases, the same circle, but tell whether the red arcs are congruent. So if you print, you might not be able to see the red, but looking on here, you can see the red arcs. So in letter A, it does not matter that these circles, well, first of all, these are concentric circles, remembering vocab from the other day. But concentric circles where this angle is 110. So this arc is going to be 110 and this arc. Now, how long they are is different. So if you think about going around a track and having the inside track is different, but the actual measure of the arcs, the measure of the arcs are equal to each other because they are both 110 degrees. The length, so how long they are not congruent. In B, we have the fact that all three angles here across that straight angle have to add up to 180 degrees. So we can find out that that angle is 65 degrees. So that arc is 65 and that arc is 65. In this case, because the circles are the same, the measure of the arcs are congruent and the lengths are also congruent. And lastly, in C, because this diameter is 12, we get 6 and 6. These are essentially the same circle. They're the same size circle. So when you have a 90-degree angle and a 90-degree arc, and you have a 90-degree angle and a 90-degree arc, same as in B, the measures are equal, and then also the lengths are congruent as well. So it's only in this case where in A, where the lengths would be different because they're different size circles you're talking about. Which is connecting to a couple of these theorems here with circles are going to be congruent. They're going to be the same if their radii are the same. Which then means that if you have central angles, so we have a central angle right here and a central angle right here, if those central angles are the same, then their corresponding arcs are also going to be the same. We're actually going to skip number 5, and we're going to go back to that actually tomorrow. That's meant for tomorrow. So for number 6 and 7, a couple quick, easy ones to end on. So if we can pause it and quickly solve 6 and 7, and then we'll finish up 10-2. So number 6, because AB is the diameter, we know that this arc has to equal 70 because it's going to cut the circle in half. So 360 degrees, we got 180 on this side, which means that 2x has to equal 70 degrees, which means x equals 35. We have a central angle here of 160, so that's the same as that arc, so S equals 160 degrees. We're going to keep talking about more with angles and arcs and how to name them as we move forward in chapter 10.